Okay, let's try a related rate problem. Um, it's from the AP test 2007, I believe, and they're giving us the wind chill in degrees Fahrenheit, um, with the wind velocity being v in miles per hour, and if the air temperature is 32 Fahrenheit, the wind chill is given by this formula. So, with respect to velocity, um, and this formula is valid for wind speeds 5 to 60 miles an hour. So they want us to find the derivative at 20 miles an hour. So that's definitely in our range. Um, so we're going to use a calculator to crank this out. But they want us to talk about this in terms of the wind chill. So I've already put this in the calculator, you can see. And I zoom fitted my window so that I can see it. And I'm just going to do a second calculation. And number 6, a numerical derivative at 20. Okay. And let's see here. Looks like we have a negative 2.8. So for part A, it is a negative 0.286. And what's the correct units here? So velocity here is in terms of miles per hour. So this is going down by negative 2.86 degrees Fahrenheit per minute. So at 20 miles an hour, that's what the wind chill, that's the rate of the wind chill decreasing. Okay. Let's take a look at something else here. Okay. I made a mistake on part A. It says using the correct units. Alright, we got the degrees Fahrenheit proper, but what did we take the derivative? Took the derivative of velocity, right? So with related rates, we're usually used to putting it over time. So whatever variable you have here is going to be in the denominator. So that's negative 2.86 degrees Fahrenheit per miles per hour. Okay. Part B says find the average rate of change. So we're looking for AROC. And remember, we're just going to think of algebra when we do that. So we're basically finding the slope of the secant line between 60 and 5. So we're going to go to our table, I guess, or we could just go to the calculator and trace this out. We have the wind speed at 60, the wind chill at 60 minus the wind chill at 5, and then on the bottom we have 60 minus 5. So we're going to take our answer that we get, divide by 55, and let's see if we can do it just like this. We'll go to trace, and we'll go 60 miles an hour, and we get 13.05. And then we'll go back and do the same thing for 5. So trace and 5, and we get 27.009. just crank through that and see what we get. Okay. And divide that by 55. And we get negative, what was that, 0.236. Alright, so this is going to be the wind chill factor per what? Per miles per hour. Okay. Okay. The second half of part B says once we found that average value, they want to know when is the average value equal to the instantaneous rate of change. So this is our W function here in the calculator. So we have to find the derivative of this. So the derivative of this part goes to 0, right? And the derivative of this is 0.16 times 22.1, and we'll have x to the 0.16 minus 1, negative 0.84. Okay, so I went ahead and put that in the calculator, and when looking for when these are equal, so if I put the derivative of this into y2 and put this value we got in the first half of part B into this one, negative 0.254, we should come up with an intersection. So I went ahead and put that in there for you. And if I look at the graph, turned off the first one, so we wouldn't see that. And let's calculate that intersection. .98. Okay. So when the velocity is equal to 22.9, whatever it was. Okay. It's kind of a tough one there. The last one says over the interval of time between 0 and 4, let me erase all this. And that says over the interval of time, the wind velocity is 20 miles an hour at time equals 0. Alright, so it's increasing at a constant rate of 5 miles per hour. What is the rate of change at t equals 3? So we have that the wind chill is equal to this function over here. And if we take the derivative of this, this is what we're looking for, right? Keep putting t there, sorry. With respect to the velocity, right? And we take the derivative of this, we get that 0.16 times 22.1 x to the, that's b actually, v to the negative 0.84, and we just took this, and we have the velocity took the derivative of this, right? So, and here they've given us that well, we are taking it with respect to time, sorry. So dv dt over here, and they gave us dv dt is equal to 5 miles per hour. Alright, so what is our velocity here? What do we plug in? Well, if it started off at 20 and it increased 5 miles an hour every hour, we're at what? 20 plus 15, so we're just going to need to evaluate this at 35. And then multiply that by 5. And that'll tell us the wind chill change with respect to time. Alright, so I think I still have this one in the calculator. This is negative 3.536. Okay, I don't really need this graph of, so I'm just going to go to this graph and trace it out for time equals 35. Make sure my window is set. X max up to 60, so that should do it. So I'm just going to trace out at 35. Copy that over here. We're going to multiply this negative 0.1784412 times 5. Should be done. And looks like it's a negative 0.892206. Alright, so it's kind of a long problem, and I hope you followed along okay.